اهلا بيكم في كايرو دار اعزائي طلبه الثانويه العامه. النهارده بنستكمل رحلتنا مع الماثماتيك وجزء جديد في الكالكولاس very important lesson and the lesson of the second chapter which is talking about the implicit differentiation. What do we mean by the implicit differentiation? Directly we can go through away from the theoretical part and try to know how to make the implicit the derivative for a function. If we have a function like that, or d over dy of y power of n, كنا بنعمل ايه؟ write n y power n minus 1 dy over dx, or we can write it as n y n minus 1 dy over dx. It was y dash. If we have example, numerical example like that, d over dx over y power 2 equals, right, will be 2 y dy over dx, or we can write it as 2y y dash. Also, if we have d over dx y power of 3, that means 3 y power 2 y dash, and this was the means of the implicit derivative. Okay, so a higher derivative now we have to talk about the new title, which is a higher derivative. As we know that d over dx of the function y was dy over dx, which is called first derivative. Now we have to differentiate the first derivative dy over dx according to the dx. This function will write it as d2y to dy dx square, and this is the second derivative. Also we have d3y over dx power 3, and this is the third derivative, and so on. This is all kind of high derivatives. Now we talked about implicit derivative and the higher derivative. Let's know about it more than that by using or solving some examples. Example number 1. If y power 2 plus 2 x power of 3 minus 5x equals 12, prove that prove what? Proves in y d2y over dx square plus dy over dx all power of 2 plus 6x equals 0. We have to, this is the solution. First we have to write down the problem. This is y power of 2 plus 2 x power of 3 minus 5x equals 12. by differentiate first to get the first derivative. Now 2 y dash plus 6x power of 2 minus 5 equals to 0. يبقى هنا differentiate to x. Okay, we have to find the second derivative. This is the product. We can say that this is the first derivative, and this is the second derivative. First في الدerivative of second y double dash plus second في الدerivative of first, this is second, multiply derivative of first, which will be 2y dash plus 12x equals 0. We have to write it again. Now we get 2y double dash plus 2y dash times y dash, this is y dash power of 2 plus 12x equals 0. By divide all the problem by or the equation by 2, that we get y double dash, which is second derivative due to y over dx square plus 2 y dash, this is dy over dx all power of 2 plus 12x equals 0, and this is the requirement. Now we proved example number 1. Let's move to solve example number 2. If y power 2 plus x power 2 y power 2 equals 8, prove that x squared plus 1 y double dash plus 3 x y dash plus y equals 0. Now let's try to solve it together. First, we will write the equation y square plus x squared y squared equals 8. By the way, the higher derivative of the requirement is the second, then we have to differentiate for the first derivative and differentiate again to x or according to x to find the second derivative. Now first derivative, so 2y dash plus, this is the product of two function, first times derivative of second, 2y dash plus second for derivative of the first, which is 2x equals 0. We can cancelling y dash, we can cancelling y dash, we can cancelling y and y, write it 2y dash plus 2x squared y dash plus 2xy equals 0. By dividing by 2, we will get y dash plus x squared y dash plus 2x, right, y, sorry, there is no 2, xy equals 0. Okay, what do you think about it? First, differentiate second derivative. We will write y double dash plus, this is the product, first times the derivative of second y double dash plus second times the derivative of the first, which is 2x, plus first times derivative of second, this is y dash, plus second derivative of first is 1. All of this equals 0. Let's simplify. Let's take y double dash as a common factor here. We will get 1 plus x squared plus, this is 2xy dash and this is xy dash. We get 3xy dash and plus y equals 0, and also we get the requirement again by using or knowing the higher derivative or the highest value of derivative here is the second derivative. Then we differentiate according to x twice for the first time and the second time. Let's try to solve another problem. If xy equals sine x cosine x, prove that d2y over dx squared plus 2 dy over dx plus 4xy equals 0. This is the solution. Let's try to do it together. Firstly, we have to write it again. xy equals sine x multiplied by cosine x. We have the greatest or the highest derivative here is the second derivative, so we have to differentiate first derivative. This is the product, first times derivative of second plus second times derivative of first equals, also this is the product, first time of x times derivative of second, which is negative sine x, plus second multiply derivative of first, which is cosine x. Now we have to simplify it. xy dash plus y equals sine negative sine square x plus cosine square x. So we have to write it again. xy dash plus y equals cosine square x minus sine square x. Let's check it together. xy dash plus y equals cosine square minus sine square. Let's try to make the second derivative. First times the derivative of the second plus second times derivative of first, right? Again to plus this is y dash equals cosine square, by the way, cosine square minus sine square. We can replace it by if we need to replace it or to solve it directly, try to solve it directly. Cosine, it will be 2 cosine x, or make it cosine x, cosine square minus sine square, it will be cosine 2x. It will be cosine 2x. So now we have to differentiate. Cosine 2x will be 2 sine 2x, 2 sine 2x. This is the derivative. Okay, now we have x y double dash plus y dash 2y dash equals 2, right, sine 2x. Now we have to use the rule of 2 sine 2x. We have x y double dash plus 2 y dash equals 2 sine 2x equals 2 sine x cosine x. Right, now we have x y double dash plus 2y dash equals 4 sine x cosine x. But sine x cosine x equals what? Sine x cosine x. By the way, cosine, we have negative here, and this is negative, and this is negative. So x y double dash plus 2 y dash equals negative 4 xy. Move negative 4 xy inside the equation, so x y double dash plus 2 y dash plus 4 xy equals 0, and this is the requirement. By the way, we have x here, we have forget to write it. This is the proof of the equation or the proof of the derivative. Let's move to another example. If xy if sine y plus cosine 2x equals 0, prove that prove what? d2y over dx square minus dy over dx power of 2 tan y minus 4 cosine 2x sec y equals 0. Let's try to solve. First, sine y plus cosine 2x equals 0. Let's differentiate 2x. The derivative of sine y will be cosine y. The derivative of y, it will be dy over dx. جميل. Plus cosine 2x, it will be negative 2 sine 2x. Now, what we have? We have cosine y dy over dx minus 2 sine 2x minus 2 sine 2x equals 0. Now we have to go to differentiate the second derivative according to x. This is the second derivative. This is the product. First, derivative of the second, it will be d2y over dx square plus second multiply derivative of cosine, it will be negative sine y dy over dx. minus 4 cosine 2x equals 0. Okay, let's divide it by cosine y. Okay, cosine y, cosine y, cosine y. Cosine y will, ignoring by cosine y, then we have d 2y over dx squared. Negative times positive negative, we have sine y over cosine y, it will be tan y. dy over dx multiply dy over dx, it will be dy over dx all power of 2 minus 4 cosine 2x, 1 over cosine y, it will be sec y equals 0, and then we proved the requirement, and this was the final example about the high derivative and the implicit derivative. Then we have finished this chapter of the calculus, and I promise you to be continued of the calculus to finish this curriculum at the end of the year. I leave you in the peace of Allah. Assalamu alaikum wa rahmatullahi wa barakatuh.